Dear students, Assalamu alaikum. We are discussing the prism and prism formula, condition for minimum deviation. Now, condition for minimum deviation. Now, dear students, as we know, in the minimum deviation position, the prism lies symmetrically with respect to the incident ray and the emergent ray. I will repeat it. In the minimum condition position, the prism lies symmetrically with respect to the incident ray and the emergent ray. That means at that time I is equal to E. I will write it here. Position. The prism lies symmetrically with respect to the incident ray and the emergent ray. That is I is equal to L. That I is equal to E. That means angle of emergence is equal to angle of incidence when the prism is in the minimum deviation position. Now we will prove this. Now look here, dear students. When the ray of light incident on the face AB and is refracted into the prism, then from figure we have when the ray of light incident on face AB of the prism and refracted into the prism as shown in figure 3rd, we have, that means at this face AB, when the incident ray is incident on the face AB and it gets refracted into the prism, at that time what we have? And the refractive index of glass with respect to the IR. At that time we have sin I divided by sin R1. This is equation first. Now, when the refracted ray incident on the face AC and emerges out into the IR, then from this figure we have, I will write it here, when the refracted ray incident on the face AC of the prism and emerges out into IR. That means this refracted ray, it is incident on the face AC and it emerges out into the IR. Then at this point what we have from this figure? Then we have a refractive index of IR with respect to glass, that is sin R2 divided by sin E. Now dear students, since we know, since refractive index of glass with respect to IR is 1 by refractive index of IR with respect to glass. Therefore, it is equal to sin E divided by sin R2. Second. Third. From equations first and third we have what we have from equation first we have A and G, that is a refractive index of glass with respect to air, that is sin I by sin I R1, and from equation third we have refractive index glass with respect to sin E divided by sin R2. Therefore, from equation first we have sin I divided by sin R1 is equal to sin E divided by sin R2. Therefore, I is equal to E and R1 is equal to R2. So dear students, what does it mean? What we conclude? I is equal to E and R1 is equal to R2 in the minimum deviation position. We conclude that when the prism is in the minimum deviation position, the reflected ray inside the prism is parallel to the base of the prism, and I is equal to E and R1 is equal to. I will repeat it. What we conclude from this? We conclude that when the prism is in the minimum deviation position, the refracted ray inside the prism is parallel to the base of the prism, that it is parallel to the base of the prism, and when it is parallel to the base of the prism, at that time we have angle of incidence is equal to the angle of emergence, and R1 is equal to R2. So we'll write it here. Therefore, we conclude that when the prism is in minimum deviation position, the refracted ray inside the prism is parallel to the base of the prism. That means when the prism is in the minimum deviation position, at that time that this refracted ray inside the prism is parallel to the base of the prism, and when the refracted ray is parallel to the base of the prism, we have I is equal to E and R1 is equal to R2. This is the condition for the minimum deviation position. That means in the minimum deviation position, I is equal to E and R1 is equal to R2. Thank you.